Hi, welcome to my integrated chemistry class. In this video, we're going to review a little bit about everything that we have saw in class. So let's start. First of all, we're going to start with alkanes. Alkanes are known as hydrocarbons that have only single bonds between atoms. In this case, some of the most common ones are ethane, propane, and butane, each one of them with their respectively formula. In this case, ethane has a formula of C2H6, meaning that it has two carbons connected single bonded with 6 hydrogens. Propane with a formula of C3H8, which means that it has 3 carbons connected single bonded to 8 hydrogens. And lastly, butane, which has a formula of C4H10, meaning that it has 4 carbons connected single bonded by 10 hydrogen. Some facts about straight chain alkanes in this case is that all alkanes end on A and E. They use Greek numbers as prefixes, and they usually use a name known as stem, which indicates the number of carbon atoms, and the suffix ane to demonstrate that it is an alkane. In this case, some of the most common ones, as we mentioned it before, are methane, ethane, propane, butane, pentane, etc. Each one of them with their molecular formula. We also have an example such as hexane, heptane, octane, nonane, and decane. Now we're going to see another type of chain, in this case, branch chain alkanes. In this case, these are based off by explaining us that the longest chain of carbons are called, it's called the parent chain, while the others are known as substituent groups. And we also know that carbon atoms cannot bond not only with 1, 2, 3, or 4, or even 4 carbon atoms, they can bond with many more, making all of the chains possible. And a little like tip is that branched and straight chains, sometimes they have the same molecular formula. And the identities of these atoms in an organic compound are usually known by their order and arrangement. Now we pass with another type of alkanes, in this case called cycloalkanes. These cycloalkanes are known by being a hydrocarbon ring, as we can see in the picture to the right. And this ring is usually known as the parent chain, and the numbering starts on the carbon that is bonded to the substituent. Some properties of the alkanes, in this case, chemical properties, are that alkanes have low reactivity because they are non-polar and have no charge. And their physical properties are that they have an intermolecular attraction compared to water, and they usually boil and melt at lower temperatures. Passing with our second part is alkenes and alkenes. First of all, alkenes are unsaturated hydrocarbons that contain at least 1 or more double covalent bonds between each carbon. Some facts about alkenes are that they are named the same way as alkanes, but the difference is that they end on ene. When there are more of 4 carbon atoms, you need to specify where the double bond is. They are usually non-polar and have low solubility in water. And since they have a double bond, their electron density is greater, so meaning that they are more reactive. Some tips to identify alkanes more easily is that the parent chain is always the longest one, and it's the one that contains the double bond. The tip number 2 is the position of the double bond that it determines the numbering. And the tip 3 is that always use a prefix to designate the number of double bonds. Now passing on with alkenes. The alkenes are unsaturated hydrocarbons that contain at least 1 or more triple bonds between each carbon atom. In this case, some facts of alkenes are that they are named the same way as alkanes and alkenes, but they end in Y and E. And they usually have similar chemical properties to alkenes, but they have a larger electron density since they have a triple bond, and the parent chain is also the one with the triple bond. Passing to our third part, there are hydrocarbon isomers. First of all, we need to know what is an isomer. An isomer are usually two or more compounds which have the same molecular formula, but different molecular structure. In this case, the third type of isomer that we have are structural isomers. The structural isomers have the same chemical formula, but their atoms are bound in different arrangements. Here we have some examples, such as pentane and 2-methyl-butane. And some fact about structural isomers is that there are only two types of isomers, which are structural isomers and stereoisomers. And the properties are often defined by the structures of the substance. Here we have some examples, such as cis, and trans. In this case, the example that we saw before are some examples of stereoisomers. In this case, we have some explanations about this, is that cis means on the same side, and trans means across. And from the stereoisomers, we have another type of isomer that is geometric isomer. There is a type of isomer that results from the different arrangements of the elements in the double bonds. Now we have our third type of isomer that is optical isomer. In this case, these isomers result from the different arrangements of 4 different groups around the carbon, such as a reflection. Some facts about the optical isomers are that when a polarized light passes through an optical isomer, it changes the position of the elements, first to the right with the D isomer and to the left with the L isomer, causing the optical rotation effect. Passing to our last part, the aromatic hydrocarbons. First of all, aromatic hydrocarbons are usually known by being unusually stable, compound with ring structure in which they share electrons. Here we have some examples. Before moving on, we have to know, first of all, what is a benzene. A benzene is the parent compound of the large family of organic compounds, which one of them being the aromatic compound, and is usually represented as a ring. Some facts about aromatic hydrocarbons are the following. They are called aromatic since the benzene that is inside the compounds have a pleasant smell. And there are other compounds known as aliphatic compounds, which involve the heating of animal fat and are produced by the alkane, alkene, and alkene hydrocarbons. Thank you.